Welcome back. In the previous lesson, we talked about the terminology of image and image processing. Now let's see some hands-on stuff on image processing with OpenCV. Okay, so let me open my command prompt and make sure you activate your virtual environment. Since I'm in the installations folder, let me go back, which is cd dot dot, and you can go back to my one OpenCV by again cd one OpenCV. Now let's open the Jupyter notebook and we will work on all the stuff in the Jupyter notebook. Okay, let's type Jupyter space notebook and this will open the Jupyter notebook. We have successfully opened the Jupyter notebook and you can notice that we have a folder named data, and inside the data we have a couple of files, that is flying_bird.jpg and mail_000 and one video file is there. We will work on this data. Let's go back and open the Jupyter notebook by click on new and Python 3. Okay, now let me name the notebook as 01, which is my values and pixels or pixels. So here in this lesson, let's try to understand what is values or pixels. In the previous lesson, we already looked into the values or pixels, which are actually the values inside the image. Usually for an 8-bit image, the values or the pixels in the range from 0 to 2 to the power of n minus 1. And that's what we understand, right? Now here what I'll do, let me generate some values and try to render that in an image and see how exactly we can able to get. Okay, for that let's import numpy as np and also import matplotlib, which is import matplotlib.pyplot as plt. Numpy is a numerical Python and matplotlib is a visualization library. Now let's execute this. As we know, in the previous lesson we discussed about the image and the range of values is between 0 to 2 to the power of n minus 1. So for an 8-bit image, the values could be in the range from 0 to 255. So what I'll do here is let me create an array in the range 0 to 255 and the size of the array is 16 by 16. Let me create this. For that, let me take arr is equal to, I'll use simple numpy, which is arr.arrange. That's the one way we can create the values in the range of 0 to 2 to the power of n minus 1. So what I will do, 0 to 256, so that I can able to get the values from 0 to 256. Now the step is equal to 1. And now let's print the array. Now you can see that we have the list of values in the range of 0 to 255. Now the next step is let me convert that into the 16 by 16 array. So which is arr is equal to arr dot, I can simply do the reshape and the shape I want here is 16 by 16. Now let's print arr. And here you go, this is my 16 by 16 array, which is a 2-dimension array. And in the previous lesson, we talked about the any 2-dimension array is a grayscale image, right? So this is a grayscale image and the values in the range from 0 to 255, and the lower the value is black in color and the higher the value is white in color. Maybe the middle values is pretty much gray in color. Let us visualize this and let's see how exactly we can able to get. In order to visualize this array, we need to convert the array into unsigned 8-bit integer because 8-bit image is a data type of unsigned 8-bit integer. So let me convert that into 8-bit array, which is equal to arr dot, you can use as type, and now the data type could be np dot unsigned 8-bit integer, which is int 8. This will be my array. Now we can simply visualize this using the matplotlib here. I can use this matplotlib and that I can simply visualize this. Let's visualize this using plt.mshow and saying that I'm converting that into the image, and X is an array I need to provide here, which is ARR underscore 8-bit. And the next thing is a color map. Usually matplotlib assumes that image is an RGB array. Since we are having the two-dimension array, so the color map will be the gray. And now let's execute this. And here you go, this is what an image what we're having with us. What you can notice is that as per definition, that lower the values are dark color and higher the values are white in color. That's what exactly which we have. And you can notice that there is some small boxes, or basically called pixels, and the values defines the color intensity. Cool, this is how we can generate an image. Alright, what I'll do, let me also remove the axis so that it will be much more clear, which is plt.axis, and I will put off. And finally, I'll put plt.show. Okay, so this is what my image.